In this question, we are required to find the gradient of this curve at the point 0, 1. Now, for us to be able to find the gradient of this curve at this point, we need to first of all find dy over dx and then substitute the point 0, 1 in place of x and y in dy over dx. So, to find dy over dx, we shall differentiate this curve implicitly. So, d over dx of e to power xy plus d over dx of ln y squared plus d over dx of e to power y will be equal to d over dx of 1 plus e. Now, here you can see that here we have a function inside a function, which implies that we are required to use chain rule. Now, the derivative of e to power something will just be e to power something. So if we start with outside, that will just be e to power xy. So we'll have e to power xy. And then the derivative of inside will be derivative of xy. So I'll just write it as derivative of xy. I'll sort this out later. Then plus, now here again we have a function inside another function. So if we start with the outside, the derivative of ln of something will be 1 over that. So that will be 1 over y squared. Now the derivative of y squared, again you apply chain rule, that will be 2y dy over dx. And then plus the derivative of e to power y, again the derivative of e to power something will just be e to power something. The derivative of y is dy over dx. And then here will just be equal to 0. Okay, now at this point, we come back to this portion here. Here we have a product of two, yeah, functions. So basically, we have to apply product rule here to find the, derivative of that. So we'll have e to power xy multiplied by x multiplied by derivative of into a bigger bracket. So x multiplied by the derivative of y plus y multiplied by the derivative of x for this portion, plus this is same as just 2 over y dy over dx, and this will be e to power y dy over dx will be equal to 0. Now back to this point, here we have e to power xy multiplied by, so this will be x dy over dx plus that will just be y, because the derivative of x is 1, plus 2 over y dy over dx plus e to power y dy over dx will be equal to 0. And then here we can expand the bracket. Actually, there's no point. Let's just leave it like that because we are interested in finding the gradient of the curve at the point 0, 1. So we can go ahead and say that at the point 0, 1, so at the point 0, 1, what you're interested in is to find dy over dx. So we substitute 0, 1 in this equation basically, yeah. So here we'll have e to power 0 here, because 0 multiplied by anything is 0, and this will be 0 plus 1 plus this will be 2, because 2 over 1 is 2, so 2 dy over dx plus e to power 1 dy over dx will be equal to 0. So basically what we end up with here is 1 plus 2 dy over dx plus e dy over dx is equals to 0. So that implies that basically 2 plus e dy over dx will be equal to negative 1, and therefore it follows that dy over dx will be equal to negative 1 over 2 plus e.